floating point number. In fixed point numbers, you learned that integers can be expressed. However, the number of bits is fixed, so the range of the numbers is limited. So then, how do you represent very large numbers and fractions? The representation method in which these kinds of numbers are handled on a computer uses a floating point number. Let us think about the decimal numbers that we use every day. We usually know the idea of writing the numbers in a form of exponential notation. When we need to represent very large numbers, we can omit the trailing zeros by use of exponent notation. In the same way, we can omit the preceding zeros for very small numbers. Example 1, Example 2. By always multiplying by the exponent of 10, we can represent very large or very small numbers. In Example 1, the two pieces of information, the number 25 and the exponent 7, can represent the original very big number with fewer numbers. The representation method that uses this characteristic is the floating point number. Let us think about this with regard to the binary numbers. Example 3. As you can see, there are many representation methods for binary floating point numbers. Because of this, it is necessary to unify them into one as data representation in computers. Thus, the exponent is adjusted so that numbers other than 0 can be located at the first position after the radix point. This is called normalization. The representation method of floating point numbers are defined based on the normalized representation, 100.1011, base 2 equals 0.100111, base 2, times 2 to the power of 3. The idea of how to represent floating point numbers are summarized as follows. In this format, the floating point number is separated into three parts: the sign bit, the mantissa part and the exponent part. The three parts are then stored. The number that becomes the radix for the exponent is either 2 or 16. Let us think about a 4-byte length floating point number as an example. 1. The sign bit is 1 bit, and it is 0, if the original number is 0, or positive, and 1 if negative. 2. The exponent part is represented with 7 bits. In consideration of a negative exponent as well as a positive exponent, we have two representation methods. A. The exponent part is represented in the same format as that of a fixed point number, and the negative number is represented in 2's complement. B. In the case of the power of 0, it is represented in 7-bit binary as 100. 0000, base 2, and when it is bigger, it is represented as raised by the power of 1, raised by the power of 2 and so on. When it is smaller, it is represented as lowered by the power of -1, lowered by the power of -2 and so on. It is also called excess notation. 3. The mantissa part represents the normalized fraction part in 24 bits. Example of internal representation of a floating point number. Floating point numbers are used in calculations, such as engineering calculations. They can represent a wider range of numbers than fixed point numbers. When the operation result exceeds a value that can be represented, this is called overflow. When the results are too small to be represented, this is called underflow. In the case of a numeric value that cannot fit into the mentice part, the value is truncated midway, so an error occurs. For example, in representing a number like decimal 0.1 in binary, it becomes an infinite fraction, so the value is truncated midway, and an error occurs. The reliable digit of a numeric value is called a significant digit. The significant digits of a floating point number are determined by the length of the mentice part. The method of increasing the length of the mentice part to increase precision of the numeric value is called the double precision floating point number method. The method of expression in 32 bits that you have studied so far is called the single precision floating point number method. Supplement. IEEE floating point number format. Under the IEEE standard, the format for single precision floating point numbers uses a base of 2 and contains 1-bit sign bit, 8-bit exponent part and 23-bit mentice part. This format gives priority to the range of numbers that can be represented even though the significant digits are decreased. The IEEE format for double precision floating point numbers is composed of 1-bit sign bit, 11-bit exponent part and 52-bit mentice part. IEEE single precision floating point numbers.